Hello everyone who are all watching this video. If you hear any kind of background noise, I am apologize for that. With that said, my name is Adhavan and it's my pleasure to acknowledge you with my teammates Kurunjilan, Kaushik, Giridharan and Johnson Daniel. I am the team lead of Team 7 representing from KCG College of Technology, Chennai. In this video, we will demonstrate about how we use blockchain technology to solve one of the critical applications which need utmost privacy and security to safeguard millions of records. Yeah, as you guessed it right, we are talking about healthcare management system. So basically, that's what our use case is all about: building a health data management system using blockchain. So before we talk about our solution, let me get you through a quick glance about what's the current day EHR system problems. So that we can get a better understanding about what's our problem statement is. So traditional EHR system stores the data in a centralized manner, which itself leads to several problems like single point of failure, vulnerable to data theft, data interoperability. These are some of the problems we are facing in our current day EHR system. To tackle this problem, we are using blockchain technology to solve it. Blockchain itself is a vast topic, but here is a simple definition about blockchain. Blockchain is a distributed immutable database system which can store data but we cannot able to delete it. With that said, the database is shared with everyone on the network so that if any one of the node tries to compromise it, the other peers in the network cross-check it with their record to verify the data integrity. So this is a promising technology which has the potential to solve the existing centralized database problems which need security and data interoperability needs. With that, let's move on to our solution. So we will give you a brief overview about how our chaincare network and how it works. For demonstration purpose, we set up a network with 3 hospitals and an insurance company in which the hospitals can send the patient, doc and admin details in the blockchain, and additionally we added a feature in which the hospital patient claims the insurance from the insurance company and they can send the bill receipt in a private manner which is implemented in the private data collection. Now you guys have a question like, what does even the private data collection means? We will talk about that in the later section at the time of the private data collection demonstration. First we will see the data flow of the typical blockchain system. When a user or admin sends or query data, it routes through a backend server which is connected with the blockchain network and process or get the data and routes through the same server and finally receive to the client end. So this is how the basic blockchain system works. The main difference between the centralized server and the blockchain is the blockchain data are distributed to everyone on the network, where a typical centralized server keeps the data in a single server, which leads to the problem that we mentioned before. Choosing a blockchain framework is a critical thing, and we choose Hyperledger Fabric as our blockchain framework because Hyperledger Fabric is a permission to blockchain system with tons of customizabilities in each layer, and it is created by IBM and hosted by Linux Foundation. Now let's see how the chaincare blockchain network works. Before setting up the network, we have to decide who are all the participants. We have already decided it. It is going to be like 3 hospitals and an insurance company. We will start the 2 hospitals, hospital 1 and hospital 2 at once, and then the 3rd hospital and the insurance company. The command for is like, first of all move to the test network, and we have to open the network by using this command, and we are creating a channel with certificate authority certificates and a CouchDB instance, as I said before, for saving the state database files in there. As you can see, it's just showing creating a fabric testnet with the creating a CS server for the hospital 1 and hospital 2 and a CA order. The order is the one who is responsible to order the each and every transaction in the blockchain. These are all the TLS certificate. We will talk about this in later. There are a bunch of certificate has been generated as of now. As you can see, the certificates are generated and they are joined in the channel. Let me show you. Yeah, the peer 0 of hospital 1 and peer 0 of hospital 2 has been created with 2 CS certificate authorities and the 2 CouchDB instance. And another special thing about Hyperledger Fabric is each peer is hosted inside a Docker container, so it is easy to manage and lightweight when compared to other typical peer hosting applications, and it is well suitable for a production environment because Docker containers are easy to manage and it is well suited for our production environment also. You can also notice there are some bunch of certificates as I mentioned before. um, these are all TLS certificates. The certificates are nothing but to verify and prove the uniqueness of each peer. We use certificate authority to generate the TLS certificate. It is like an X.509 certificate, which is a type of certificates which is built on public infrastructure. Let me just show you what are the certificate looks like. Let me go into the hospital one. See, as you can see, this is an XO 500 certificate, which is an 256 bit um, hash key. This is also generated for hospital 2 also. For demonstration, we had used the Fabrics here, the Fabric inbuilt certificate authority. But in real world scenario, there can be also like traditional certificate issuers like Google or Kaspersky. We can also embed them in our network. Once the certificates are created, we can join the two peers in the hospital channel, which is the main channel which gonna hold every transaction of the chaincare network. Let me just show you how it's look like. This is the main channel which holds the every transaction. These are the transaction happened in the chaincare network. You can inspect and go and see them. What are the transaction and what are the read write sets we can see in here. This is not the one we did before, because this is the final result when we spin up every network and install the chain code. So we will see that in the later part. If you have noticed, we're using another keyword called couchdb when we spin up the network, and it is the preferred database to store the state data. And another database which is in the hyperledger fabric is leveldb, which does not give as much flexibility as we want, because it is just a key value pair, and we don't use that much. And this is how the couchdb database would look like. It is an web UI provided by couchdb as an inbuilt data visualizer. You can see the JSON state files. As you can see, we have the admin credential, doctor credential, and the patient credential with the personal details. When you click the JSON tab, you can see the each individual JSON data. This is for the visualizing purpose. So with that said, let's move on and spin up the other two organization. I will speed up and we just move on to the deployment of chain code. Let me just go into the third organization and spin up the third organization. Yeah, the third organization also joined in the hospital network, and then the insurance only left on. Yeah, and finally the insurance company also joined in the channel network. We will see that here. Yeah, as you can see, we have four organizations: hospital 1, hospital 2, and hospital 3, and then an insurance company with their couchdb instance and the certificate authority also. As you can see, the peers and the CS and the couchdbs are all ready for the smart contract deployment. Now it's time to deploy our business logic named as chain code. Chain code are nothing but the function that the peers can perform. First of all, we install the chain code for the three hospitals, and then finally for the insurance company. Just go back, just put this command. We are basically using JavaScript to write this business logic. Let me just show you how the logic would look like. Chain code. We have libraries and we have the primary JSON contact. As you can see, these are all some of the chain code logics. I will just show you an overview of what are the chain codes functions we have been coded, and these are the functions we have been deployed. These things are all defined in the chain code. There are some functions we defined as of right now. It can be customizable as per our need. Now we have to deploy the chain code in insurance company also. So this script will deploy the chain code for the insurance company also. Yeah, as you can see, the chain code has been deployed for the insurance company. So now we will do some transaction, and we'll show you how we send the API request from the client side to the chain code. because doing in terminal is a bit boring, so we will show you how we do that in from the client side. So that for basically we built some postman requests. So let me just spin up the postman server, and then I'm going to do like npm start. When I did this, the server side files would got trigger. Basically they got some error. Okay, we already got this credential, we have to delete this. Now let's start it again. Yeah, as you can basically see, we getting each credential for the each doctor, hospital, and patients also. So with this credential, they can use it like an user ID and password. When you just click it, they got some public ID as well as some private key. Yeah, so let me just spin up this postman. Okay, let me just clear these things. I already tested it before. So first of all, we basically do some login thing. I will log in from admin itself, right? First of all, I log in from admin. Let me just log in from the admin 2. This is the this is the routes we have defined. This is for login, and for admin we use admin route for delete and register purpose, and we have a special route for registering doctor and patient, and for query one route, and for private data collection we are using another route. We will first see how admin create a patient with some basic details. Once the detail is passed through the server and to the blockchain via the admin credential. In the same way we can also create for a doctor. Let me just I'm just waiting. Yeah, as you can see, the patient ID is created and successfully registered the patient ID 6. Successfully registered patient ID. If you are not sure it is registered, just go to the CouchDB database, admin pw, and then go to the chaincare, and you can see admin 6 is registered with some basic details. And you can also create for doctor also with some basic doctor details. Let me just, the server is running, I'm trying to send. Yeah, it's connected, and yeah, as you can see, it successfully registered and enrolled the doctor ID 5 and successfully registered doctor ID 5. You can see successfully registered. We can and check this from here. As you can see, the doctor 5 is now created. We didn't mention for doctor 4. So we can also do some other and if you want to check the history of transaction, you can use the Hyperledger Explorer to verify it. Let me just show you. Yeah, as you can see, these are some recent transaction from the admin, because admin hospital one admin only register those things. For the let me just show you what he just registered. He just registered patient ID 6 with some file, and this is the transaction ID, which is a hash, and who are all the enrollers. As you can see, we are just keep the limiting with 3 hospitals. The 3 hospitals can only enroll. The insurance company didn't have the permission to enroll. I will explain about what does enrollment mean, and this is the another transaction shows you about. We just registered doctor ID 5 right here. These are the basic details and the transaction ID. I just trigger another transaction to show you the real time notification it will send. So I also didn't mention it here. It should be from hospital. Yeah, it is hospital organization, and I'm just trying to send this. We will see the no here. As you can see, the doctor 4 also enrolled. We just got a notification. Block 15 has been added. and the block 15 is, we can go and see the transaction ID, and see here we have some right sets, and here is the doctor 4 ID has been created. We can also do some query operation, like the admin can query the patient data and doctor data to know about them. Let me just do some query. As you can see, we queried data about doctor 81, and as you can see, the query data also shown up here, and also we can do some patient query also. As you can see, you can get the query of patient ID also. So these are all some of the APIs we have created for to simulate the client side application. If you want, you can pause and check out each and every API request. But we also got another organization like insurance company. Can they also able to create doctor and patient IDs? To sort out this issue, we have the endorsement policy and read write functionality access that we can use it to restrict certain organization. Endorsement policy is nothing but it is used to restrict certain organization to not to verifying any transaction. They are present in the network for just data querying and for private data collection. With that, you can also guess another question, like even though it is a closed network, but what if we got one hospital has a malicious actor trying to steal the data from the blockchain network, because the data has been available in public for every organization in the network. For that, there is a feature in the Hyperledger fabric called private data collection, which keep the data private from other organization. Then they can't able to see the data because it is all encrypted. Only the hospital which implements private data collection, can able to see the private data. As of now, we got some working issue in the private data. It works fine in the terminal, but for some reason it doesn't work as we want in the API connections. Here is a scenario for private data collection. Hospital 1 sends a quotation stating that the patient ID 0 needs insurance, so that the insurance need to cross verify the patient ID and issue the insurance. As of now, we don't take care of payment. We only store the bill receipt in the blockchain. The insurance sent the paid receipt, which is now saved in the blockchain, but the other organization did not know the bill existed, but they know some private transaction like happened, because only the hash only shows in the blockchain. We demonstrate for bill receipt scenario. It is possible to store any data in the private data collection, like keeping patient details. Okay, as of now, we try to simulate the private data collection in the terminal. So first, the hospital 1 is trying to create the bill. Initially, he asking the insurance company to provide the insurance. So we try to basically create a private data collection. We just gonna run this script, because it says like patient ID and the patient name is going to be like other one, and the bill amount is like the string, the bill amount receipt, which I just give some random string. You can be considered like as an Google Drive, the document link or IPFS link, anything like that. And public description we provide is like provide the insurance, so that then the insurance company can see it and let them know that they have to provide an insurance. So we try to deploy this, run it, and as you can see, we have invoked it successfully. If we have to check it right, so first of all we check from the hospital 1 side, is there it is deployed correctly. We try to query it. Yeah, as you can see, the patient ID 0 and the name is Adhavan, and this is the owner. As you can see, the hospital 1 admin is the one who initiated, and the public description is like provide insurance. And you may have the question like where is the string? The string is now inside the private data. So this is like publicly available to everyone, and the string is only available to the insurance and the hospital 1 organization. So we just check it out, right? We want to check it, right? Try to deploy. oh sorry, I mentioned like patient ID 1. We use patient ID 0 to check it now, and we tried. As you can see, the patient ID 0 and the bill amount, just consider this as an link. This is the bill receipt link. If you try to click it, and we get to go into the browser and see the receipt. This is only stored in the private data collection. So we can see the bill is created by the hospital 1 and he can see it. But if you want to the thing is like insurance is the one who want to check it, right? So we can check from the insurance side. I just changed the environmental variables. Necessary certificates has to be given and try to access it. When I try and deploy it, sorry, I didn't save it. I got some error. Yeah, when I try to access it from the insurance, it is provided. It can be seen from the insurance point of view. This is created by hospital 1 and the name, and he can see the bill receipt. The bill receipt is mentioned like provide the mentioned is okay. The bill receipt can be mentioned like the quotation of how much amount that needed for the patient to be insured. This kind of details can be provided. So once the hospital received, they can query about they can query and read about the patient details, and if they verified it, they can now change and update the bill. As I said before, we don't really consider about the transaction. We just only storing the receipts in the blockchain. So now we try to invoke the transaction from a insurance point of view. We're just gonna change some new string. Maybe I will give like the IPFS style QEM and some random gibberish. This is the one, I think so. Yeah, some random gibberish. And yeah, we will try to invoke first and then we try to query. Now the environmental variable is set to the insurance, and now we try to access it. Provide insurance, like we have to change this. Insurance is paid, bill receipt is added. I'm not sure the receipt spelling is correct. Okay, now I try to trigger it. We got some error. Why? Because we are trying to create it, but the thing is we want to just update, so we just change this function, update bill. It's gonna take the same parameters as create bill. So now we can run. As you can see, now the train code transaction has been invoked. Now we will check from insurance point of view. Just uncomment this and try to access both. As you can see, the newly created what? I think some sort of problem has been here. The bill amount is not updated, I think so. Why? I created a patient ID. Insurance is paid, bill receipt is added. Okay, I think if we query from organization 1, we get the same thing. But if we query from organization, okay, sorry, I'm just reading the wrong bill. I want to read organization 2 bill, which is the insurance bill. That's why this problem. Now as you can see, this is the new bill stored in the private organizations of the 2. We demonstrate for bill receipt scenario. It can be possible to store any data in the private data collection, like keeping patient details in the private data collection is also possible. With that, we comes to the end of the backend and the server side works. As of now, for the front end part, we only designed it, we didn't implement it. We don't have enough time to do that. That's why we're using Postman to simulate the front end transactions. This is how our front end looks like.
we basically have a login page. You can log in as patient or doctor or admin. Just consider like for now we just log in as admin. If we log in as admin, we get two buttons of register patient or register doctor and some basic details about the admin. If you want to register patient means if we click that, we can basically register some basic details about the patients. And if you want to register for doctor, you also can basically register some basic details about the doctor. And it's all about further the patient has to log in and upload their own details, and the doctor has to update their own details. These are all some of the pages we have been designed. Finally, as of now, we deployed this network in our local instance, but in production network we don't usually do like 4 peers in a single in a single system. We just distribute each peer in separate containers in Kubernetes clusters. We can also use their own servers, or we can leverage cloud providers to do this stuff. With that said, we just comes to the end of the video. I just hope we just give our best to build this application, and we try to demonstrate it as good as possible, I think. So thank you Virtusa for giving this opportunity to demonstrate our technical skills, like building an application like this. And thank you for bringing up this new technology like blockchain into the students' hands, because this is kind of technology usually students not get to know about this. It is a great learning experience, and we hope that we will clear this round and move to the next stage. And I hope our teammates will do have the same hope. Thank you on behalf of Team 7 and from the KCG College of Technology. Thank you, sir. My name is Adhavan, signing off.